Hey there, kiddos. In this lesson, we'll be once again going through how to solve ratio problems, and instead of using a tape diagram as our model, today we're going to be using our table. And so let's take a look at our question and keeping in mind our vocabulary that we've been going over the last couple of days or the last couple of lessons. What are like quantities, unlike quantities, equivalent ratios. And then today, some new vocabulary is going to be the multiplicative inverse or the additive inverse, meaning that you're going to multiply or be adding. And we're going to make sure that we're keeping in mind scalar multiplication, which is when two values in a ratio are multiplied by the same factor in order for the ratio to be kept the same, or in order for the ratio to be equivalent. We're going to be going through the same three criteria for success, where we're going to, one, want to make sure that we're annotating. Two, making sure that we have a model. In this case, our model is going to be the table. And then three, make sure that we are answering whatever the question is asking us. Cool. So let's take a look at it. It says, in order to make paper mache, the art teacher mixes water and flour. For every two cups of water, she mixes in 5 cups of flour. So what are the two things that we are comparing? We have water and we have flour, which we can see here. I'm just going to just write in 5 because it tells us, hey, for every 2 cups of water, we got 5 cups of flour. So now, how do we fill it up? Well, scalar multiplication to go from 2 to 4, we're multiplying by 2. So we're going to do the same thing here. We're going to multiply by 2. 5 times 2 gives us 10. If we have 2, then 4, this is blank, and then 8. I'm going to assume that if we're going to follow the same pattern, it'd be 2, 4, 6. Well, to go from 2 to 6, we'd multiply by 3. So to go from 5 to this unknown, we get, once again, use scalar multiplication, multiply by 3. That equals 15. Now to go from here, if we were to use the pattern again, from 2, 4, 6, 8, and then this unknown, well, we have to first fill in the 8. So to go from 2 to 8, we're multiplying by 4. So to go from 5 to this unknown, we multiply by 4. 5 times 4 gives us 20. Well, to go from, now on this side, we don't have the number of cups, but we do have the number of cups of flour. But to go from 5 to 25, well, we're multiplying by 5. So we're going to do the same thing here to multiply 2 times 5. Well, 2 times 5 gives us 10. What about here? We have the cups of flour. So to go from 2 to 20, we're multiplying by 10. So we're going to want to do the same thing over here to go from 2 to this unknown number. If we multiply by 10, 5 times 10 gives us 50. And what about the last one? Well, from the last one, to go from 5 all the way to 75, well, what's 75 divided by 5? That's equal to 15. So we're multiplying times 15. We're going to want to do the same thing over here. 2 times 15 gives us 30. So what can we say, or what do we see is true about each of these pairs on this table? Well, first thing we could have said is, well, to go from 2 to 4, we know that multiplication is repeated addition, so we could have just added over and over and over again. That could have been one thing that we could have seen in order to make sure that the relationship between each group on this is kept constant. But we also see that we could have used multiplication because we know that multiplication is just repeated addition, so multiplying is going to be a bit more efficient. When we're unable to multiply, sure, use addition. Or if we're able to use addition and we see that it's the same addition that's occurring over and over again, then yeah, to be a bit more efficient, we're just going to want to use multiplication. However, if anyone were to ask you, hey, is this table equivalent? Are the ratios to the cups of water, comparing the cups of water to the cups of flour in order to make this paper mache, is it equivalent? We would say that yes, the ratios in this table are equivalent because for every 2 cups of water, there are 5 cups of flour. Excellent. Let's go on to our next question. So in your composition notebooks, you should have the following written down. You should have, first off, this is Unit 6, Lesson 6, so 6.6 should be in the top left part of your composition notebook. Our same 3 steps are still going to be the same. Alrighty, let's move on to the next question. The next question reads, we have the following table where it says spraying plants with cornmeal juice is a natural way to prevent fungal growth on the plants. It's made by soaking cornmeal in water and using 2 cups of cornmeal for every 7 cups of water. So once again, number 1, what are we going to annotate? What are the 2 terms that we are comparing? Well, we see that it says we have cornmeal in water, and we have 2 cups of cornmeal. So we have cornmeal to water for every 7 cups of water. So 2, 7. We're then told complete the table below for 2 cups of cornmeal, 4 cups of cornmeal, 6 cups of cornmeal, and 8 cups of cornmeal. So we have a couple things we could do. One, we could use addition because we see that we're just adding to, and adding to. Or we can use multiplication where we see to go from one to the next. Let's use multiplication. I'm going to use multiplication because that's a bit more efficient. So first thing we see is to go from 2 to 4, we're multiplying by 2. So to go from 7 to what's here, we multiply by 2. 7 times 2 is 14. Next, to go from 2 to 6, we're multiplying times 3. So from 7 to here, we multiply times 3. That'd be equal to 21. And then last but not least, if we're going to fill up for 8 cups of cornmeal, we're multiplying by 4. We do the same thing here, times 4. 4 times 7 gives us 28. Now, we're asked in part B, how many cups of water should be used for 48 cups of cornmeal? So if we're going from 2 to 48, from 2 to 48, that means we're multiplying by 24. So we would do the same here, 24 times 7. This would be 168 cups of water for our cornmeal juice. So we would have how many cups of water? 168 cups of water. Last, how many cups of water are needed for 288 cups? So now, 288 cups. So to go from 7 to 288, so this would be 4, and nope, that'd be 1, and then we have 1 left over, so it'd be 41 and 1/7. We're just going to round this to 41. How many cups of water are needed for 200? Oh, Mr. Pierre made a mistake right there. Looked at it wrong. Let's erase that. It's supposed to be 288 cups of cornmeal, and we're looking for the water. We all make mistakes. Mistakes are proof that you're trying. So if we divide that by 2, it'd be 144. So we're multiplying by 144. If we do 144 times 7, that's 8, carry the 2, that's 30, carry the 3, that's 10. So that would be 1,008 cups of water for 288 cups of cornmeal. This is a good example here, the mistake that I made. Now we want to make sure that we're reading it carefully, and then we're using the table that we have here in order to verify that, hey, the work that we did, the math that we did actually answers the question. So we did. Step number 1 was to make sure that we annotated. We did that. Step number 2, we're using our model. In this case, the model is the table. And then step number 3, did we answer the question? I nearly answered the wrong question, but thankfully I had my model in my table to see, hey, where did I actually write that 288? Did I do it correctly? Yes, I did. Let's do one final part A together. And actually, let me go back, give you a countdown so that you have enough time to copy this down. This will be going away if you need to pause so that your notebook has all of this and catch any of those mistakes that Mr. Pierre might have made. Maybe you made the same mistake too. Catch it before we move on and going away in 5, 4, 3, 2, and 1. All right. We are told that the local radio station schedules 1 minute of news for every 10 minutes of music. We want to complete the ratio table below, then use it to answer questions A through C. We are going to just be answering answers A through C when we get to class. With your partners, this is what you will be answering in class. So we'll just do A through C. For every 1 minute of news, there are 10 minutes of music. So we see that to go from news to music, we're multiplying by 10. Multiplying by 10, multiplying by 10. Well, to go from music to news, it's the inverse. So if we were multiplying, what's this going to be? This is going to be divide by 10. So in this case, 40 divided by 10 is 4. 60 divided by 10 is 6. What would be in between these two? Well, we go from 40 to 60. Increments of 10 would be 50. And if we divide by 10, this would be 5 minutes of news. So what's the ratio of music, of the minutes of music? So minutes of music is first, and then news. Music is 10, news is 1. Or if you wanted to write 10 to 1 or 10 to 1, that's fine. How many minutes of music would the disc jockey or the DJ have to play for every 60 minutes of music? Well, as we saw on the table, there would be 6 minutes of news for every 60 minutes of music. And then how many minutes of music would the disc jockey have to play for? 8 minutes of news. Well, we see that the ratio of minutes of news to music is 1 to 10, or the minutes of music to news is 10 to 1. So because this is 8 minutes of news, that means there would be 80 minutes of music for the 8 minutes of news. Did we follow the 3 steps? Did we annotate? Did we fill our model? And then did we answer the questions that we asked? Oh, that's a bad question mark. Let's do that again. Did we answer the question that we were asked? Cool. Alrighty, now in class, let's work on this.